Before I start and before I show you the circuit or the design I'm having right now, I just want to make two notes on this amp. I already said I like how it's built, and there's a good and bad thing I wanted to note. So the good thing is whoever was designing this at Vox, they did a very nice touch of getting rid of paint here. This is where the bottom cover is attached, and on the bottom cover you also have this paint removed, so you have continuity of the ground, so it's all one like big cage insulating you from the radio frequencies. And here you also have this paint removed. This is where the switch is, and this is a nice touch. But the bad thing in this amp, and I don't really like those tags, and the reason for this is some of them are sitting really tight and you don't want them to be loose on the connections where you have 300 or 230 AC or 300 400 DC voltage. So one of the connections you can see is really loose. It's the center tap of the secondary of the power transformer. I can easily take it off, and it's not making a solid connection. So whenever you're operating an amp and it vibrates because it's sitting on the cab, this connection will be intermittent. And I'm going to take this whole thing out and soldering these. I don't trust those connections. The way this amp will look is really simple. You have the filament heater winding, you have some ground connection, you have the screen supply connection. So this is already, all the wiring is in place. That's a great thing when you're modding an amp that's already built. You don't need to make this from scratch. In a second I will show you my computer screen where the design is. So you will have those power tubes. The power supply will be somewhere here, and I'm still struggling how to manage this space, because this is really little space for a power supply where the most of the power will be dissipated, and I want as much space as possible. So that's a challenge for me at this stage. This will be the phase inverter, and this will be the V1 tube. So we will have some phase inverter wiring around here, V1 wiring like the cap to the ground and cathode resistor and things like that. And I have reviewed the DC filament supply, and I don't feel like I still have a space to put another 3 mid-size caps in here. Maybe I will, but for now I'm designing for AC filaments for all these tubes. Maybe the Vox did the DC filaments to get rid of the hum, because it's all so tightly packed that you will get more hum than usually you get from the regular design. So if that happens, if that's the case, I will review and go back to DC. For now it's all AC filaments, AC heaters, supply. This is how it looks in the software. I was trying to show the exact dimensions that we have in the amp to be, for me, to make it easier to design over the chassis. You have the power input, power transformer, output jacks, input jack, potentiometers that you have on the amp. and the holes where tubes were located. And you also have the switch for the standby for the triode and pentode modes, power switch, the main switch, and the lamp for the power on. So this is the starting point I have to design around it. And this is how it looks after putting the components into the chassis. So I have put in the tube sockets, strip boards, and I was just wondering if I should use the strip boards, stack boards, and it seems that the best approach here will be to use the short strip boards and using the matchless approach, where as much as you can you're connecting components to each other to save space and to make it easier to work on the amp later. As I said, I'm struggling with the power supply. I have the dropping resistors for AC, diodes to rectify the voltage, and then I'm going to have two big caps. I'm not sure if they will fit. We will see. But well, here they are. And these caps will provide a output transformer supply and will provide for the screen supply, which is this node. This goes to 3PDT switch, which switches between triode and pentodes. So from this node it will give the voltage to the screens, or it will connect the screens to the plate. Then the power goes to another node which supplies the power to phase inverter, and the next mode is V1 supply. For the grounding scheme, I'm trying to make this as much by the book as possible, so I'm having the V1 ground here, then another ground for the phase inverter in the midway, and then another ground for power tubes here, and then I have another ground for the power supply for a reservoir cap here. I will be using this DPDT switch to switch between the bright cap and AC30 design is bright cap and the 330k resistor before the gain knob. So it will be, the switch will take the 330 out of the circuit and the bright cap out of the circuit. For now I'm keeping the traditional AC30 tone knob with 250k potentiometer and 4.7 nanofarad cap. AC15 had, I think it had 2.2. I'm keeping the 4.7. I'm just used to it. Heater supply is AC for all tubes. So this is heater supply, it goes to the power tubes, then it goes to V1 and phase inverter. And from here it goes to the power lamp, or power LED, which I am putting with another diode in counter parallel and resistor. For now it's 560. This is what was originally in nitrine, so I'm going to be using 560.